Welcome back to this chemistry class. In today's video, we'll be dealing with equilibrium. Okay, and under equilibrium, we'll be dealing with property of a system existing in equilibrium. Now, before we start, let's know the meaning of equilibrium. Equilibrium in chemistry is a state of a system where there is no observable change in the property of a system with respect to time. Now, property of a system existing in equilibrium. We have many properties, okay, but in today's video, I'll be dealing with one of the properties. Now, a chemical equilibrium can only be achieved in a closed system. Okay, in the aspect of chemistry, we are what? In the aspect of equilibrium in chemistry, we are dealing with what? Chemical reactions. How chemical reactions can attain the equilibrium state or the equilibrium point. Are you getting it? So the first one is said that what a chemical equilibrium can only be achieved in a closed system. A closed system means something that is closed, not open. It can be a closed vessel. Let's look at this reaction. This is calcium triazocarbonate 4, right? This is a compound. Another word of calcium triazocarbonate 4 is limestone. It's a solid. Limestone is a solid. Are you getting it? So another word of this is what? Limestone. Don't forget. So meaning you can either call it calcium triazocarbonate 4 or what? Limestone. Okay. These two arrows in a chemical reaction indicate forward and backward reaction. Are you getting it? These two arrows in a chemical reaction indicate what? Forward and what? And backward reaction. Okay, forward and backward reaction. So you can see that this this compound is splitting or decomposing to form smaller what? Compounds or elements. Now, let me explain the meaning of this. A chemical equilibrium can only be achieved in a closed system. Now, from this chemical equation, you will notice that carbon 4 oxide is a gas, right? Carbon 4 oxide is a gas. So, meaning if this reaction is taking place in an open vessel, like outside a container, you will notice that when the reaction is taking place, the carbon 4 oxide will what? Escaping to the atmosphere. Are you getting it? The carbon 4 oxide, since that carbon 4 oxide is a gas, it won't be stable outside a vessel. Are you getting it? So if this reaction is taking place outside a vessel, the carbon 4 oxide will what? Escaping into the what? Environment or into the atmosphere. So meaning by escaping, the chemical reaction will not what? Attain the equilibrium state or equilibrium point again. Are you getting it? For a chemical reaction to attain equilibrium point or state, all the concentrations on both the reactant side and the product side must be what? Intact. Are you getting it? It must be what? Intact. So as far as this carbon 4 oxide keep on escaping to the environment or to the atmosphere, this compound here will keep what? Decomposing to form more carbon 4 oxide. Are you getting it? I mean, if the reaction is taking place in an open vessel, the carbon 4 oxide, since it's a gas, it will keep escaping to the environment. I get it. As this gas is escaping, more of this compound will be what? Decomposing to form more carbon 4 oxide. It will come to a point, this compound will be what? Used up. Are you getting it? It will what? Used up. So at that particular point, this reaction cannot attain equilibrium state again. Are you getting it? That is why a chemical reaction that is referred to as reversible reaction will be behaving like irreversible reaction. Are you getting it? Most chemical reactions are reversible, meaning they can move forward and what? Backward. Meaning the reactants can react to form the product. At the same time, the product can react again to form the reactants. Are you getting it? So in this type of equation, as far as this equation is taking place in an open space or open vessel, the carbon dioxide will keep what? Escaping. At the same time, as this carbon dioxide is escaping, this compound will be what? Decomposing to form more carbon dioxide. It will come to a point, this compound will what? Use up. This is a reversible reaction, but it will come to a point once this compound is used up, the reaction will what? Behave like an irreversible reaction. So meaning before a chemical equation can attain the equilibrium point, that chemical reaction must take place in what? In a closed vessel or in a closed system. Thanks for watching. If you are watching on YouTube, subscribe for more videos. Facebook page for more videos. Please share this video. Bye.